right, 6.3, part 3. Now that we've looked at what an exponential function is and how to graph it, we're going to write some. So in this next example, okay, it gives us a lot of words, but we just need to break down what's happening. We have an exponential function g, so that's the name of our function. G is the name. Okay, models a relationship in which the dependent variable, the dependent depends on the other. So it would depend on what you put in, on what you get out. So that dependent variable is the y. The dependent variable is multiplied by 1.5 for every 1 unit on the independent, and the independent there would be our x. Okay. So I'm going to go ahead and I'm going to create a bit of a table. They want us to graph g when g of 0 equals 4. So first let's break that down. G of 0 equals 4. So that tells me 4 is the input. Sorry, 0 is the input. 4 is the out. So I know when I put in the point 0, I get out 4. So I can already start graphing this guy. Because I know when I put in a 0, I get out a 4. 0, 1, 2, 3, 4. So I know I'm going to have that point right there. Okay. But it says the dependent variable, so the y. This y is multiplied by 1.5. So to go from this one to the next one, I need to multiply by times 1.5. For every 1 unit, the independent variable decreases. So if this goes up by 1. So if this goes to 1, that next one would come from 4 times 1.5. Well, 4 times 1.5 is 6. So I already have my new point. New point 1, 6. Okay. If I plug in a 2, again, that went up by 1. So now I need to multiply by 1.5. So I multiply by 1.5. 6 times 1.5 is 9. Okay, so our standard basic exponential function, again, is a times b to the x. And again, if you remember from the last video, this a comes from normally that y-intercept. So I know my a. I know my a is 4. Now I just need to figure out what is my b. Well, your b comes from what are you multiplying each step by? What's that pattern? You multiply by 1.5. So my b would be 1.5. To help with that decimal and the multiply, I'm going to put it in, oh, not to the 5th, to the x. So y equals 1.5 to the x. So now I would double check that when for sure I put in a 0, I get out a 4. So when I put in a 0 to this, 4 times 1.5 to the 0. 1.5 to the 0 is 1. Yep, I get out a 4. Let's see, when I put in a 1, 4 times 1.5 to the 1. Do I get out a 6? 4 times 1.5? Yep, that's 6. When I plug in a 2, 4.1.5 to the 2. Yeah, you get out 9. It does work. Try it in your calculator. Okay, so there is my function. Okay, so if I go ahead and keep graphing points, it's going to give me something kind of like that. But it says in this next bit to compare the g to the function f from example 3. Well, if we go back here to example 3, there it is. This is the function from example 3. 4 times 2 to the x. They look very, very similar just by looking. They both have the point 0, 4. 0, 4. Okay, but this one goes 4, then 6, then 9 as we go up by 1 each time. This went 4, then 8. Oh, geez. I don't know how that happened. 4, then 8, then 16. This one seems to get bigger faster. 4, 8, 16 as opposed to 4, 6, 9. Okay, but if you look at the bases, that makes sense. This base here is 1.5. It's smaller than the base of here, which is 2. So compare the graph of g. F gets bigger faster. Since the base is bigger. Since b is bigger. Since the base is bigger. Okay, and we can actually look at these both side by side. I have them both in Desmos. So there they are. If you notice, okay, here's the red one. Here's the one we just did. That's 1.5 to the x. And if you notice, it doesn't get as big as fast. It's underneath the purple. That purple one gets bigger faster. It starts out slow underneath the red, but then once it hits here, then it's above the red everywhere else. Okay, so it gets bigger faster as we go out. Okay. And the last bit, just on the interval from 0 to 2. So we're just looking at this interval here, basically, from 0 to 2. Okay, oh, and you can't see me draw on that. Sorry, guys. From 0 to 2. We're just looking on just that interval. Basically, we don't want to look down here. Okay, we want to look just from here to here on what's happening. Okay, so yes, it is bigger because we know if I look down here on the other one, the other one's larger. Okay, last example. Here we have an actual real world situation. This is one place, chemistry and bacteria population where exponential functions are used all the time. The graph represents a bacterial population Y after X days. Write an exponential function that represents the population. So we need to write the equation for this. And I want an exponential function, so I'm going to write the most basic exponential function. A times b to the x. And then I want to look. My A normally comes from that y-intercept. So we want to look, where is that y-intercept? They tell us up here, it's the 0.03. It crosses the y-axis at 3. So my A is 3. Y times 3, y equals 3 times b to the x. Now, next I need to find my b. Well, what do we multiply each time? Well, if we look at this function, we've got the 0.0. I'm just pulling some points off this thing. We have the 0.03. It's got the 0.112. We've got the 0.248. So let's look. What are we multiplying by each time? Times 4. Does that stay consistent? Times 4. So my base is 4. So we now have my whole equation. 3 times 4 to the x. Now we would double check and make sure it in fact works, meaning when I put in a 3, I would want to make sure I get out a 192, take 3 times 4 to the third. So we can go ahead and get our 3 times 4 to the third. Yep, 192 seems to work. Okay. Sorry guys, wrong app. All right. So yeah, it seems to work. So there's my equation. We found it. So now that I found my equation, I can do this next part. They want me to find the population. The population is the y, population y. So I need to find y after 12 hours. So my x is 12 hours and 5 days. So it's 2 separate problems. Okay. So I first want to find it after 12 hours, but be careful. X is in days. So I have to think 12 hours to days. So 12 hours is how many days? There's 24 hours in a day, so that would be half a day. So now that I have my equation, I just need to take y equals 3 times 4 to the 1/2. Grab my calculator out. That one shouldn't be too tough. 4 to the, I'm going to type in 0.5. That's the same as 1.6. So my population would be at 6. So after half a day, my population would be at 6. Okay. Thinking at day 0, does that make sense? At day 0, there was 3. So yeah, and at day 1, there's 12. So that makes sense. Half a day, there'd be 6. It's kind of in the middle there. Okay, and then now 5 days. Y equals 3 times 4 to the 5th. So now I want to take 3 times 4 to the 5th. So I can just go back here and get rid of the decimal. 4 to the 5th. 3,072. That's a lot of bacteria. Look at from half a day or day 1, there only being 12, to day 5, 3,072. That multiplies fast. And that's really kind of how you get sick. You get 1 or 2 bacteria in you, and within 5 days, you got a lot of bacteria in you. Okay. All right. The end.